Have you ever wondered why lemon juice makes your lips pucker or why soap leaves your hands feeling slippery? These everyday sensations are more than just chance, they're the result of powerful chemical properties. Acids and bases stand apart from most other substances because of their unique behaviors in water. These behaviors or properties are all linked to the ions they produce. Acids give us hydronium ions, while bases give us hydroxyl ions. These ions are the reason for their taste, reactivity, and even their ability to conduct electricity. We can divide these properties into two main groups: physical traits that we can observe directly, and chemical reactions that reveal their deeper nature. Understanding both sets of properties helps us not only in the laboratory but also in everyday life, from the fizz of a soda to the cleaning power of a detergent. Acids generally have a sour taste, though in chemistry, we never taste them in the lab. We learn this from safe, everyday examples like lemons, oranges, and vinegar, which contain natural acids. They turn blue litmus paper red, giving us a quick visual test. When dissolved in water, acids can conduct electricity thanks to free moving ions. This is why acidic solutions are electrolytes. Many acids are corrosive, meaning they can damage skin, fabrics, and even metals, so they must be handled with extreme care. This is why lab safety goggles and gloves are a must when working with them. Bases, on the other hand, often taste bitter and feel slippery to the touch, like the slick sensation of soapy water. This slipperiness comes from their reaction with the natural oils on your skin. They turn red litmus paper blue, making them easy to distinguish from acids. In aqueous form, bases also conduct electricity because of the hydroxyl ions present in the solution. However, their caustic nature means they can burn or damage organic tissue just like acids. In fact, strong bases like sodium hydroxide can cause severe chemical burns, so protective handling is just as important. Let's explore how acids show their true power. First reaction: acids react with active metals to produce hydrogen gas. For example, zinc plus sulfuric acid gives zinc sulfate and hydrogen gas. Second reaction: acids react with metal carbonates and hydrogen carbonates to release carbon dioxide. For example, calcium carbonate plus hydrochloric acid gives calcium chloride, water, and carbon dioxide gas. Third reaction: acids react with bases in a neutralization reaction to form salt and water. Fourth reaction: some acids can act as strong oxidizing agents, such as concentrated sulfuric acid and nitric acid. From fizzing hydrogen to bubbling carbon dioxide, acids never fail to show their chemistry magic. Let's see how bases make their mark in chemistry. First reaction: bases react with acids to form salt and water. This is the well known neutralization reaction. Second reaction: bases react with ammonium salts on heating to release ammonia gas. For example, two molecules of ammonium chloride plus calcium hydroxide give calcium chloride, two molecules of ammonia gas, and two molecules of water. Third reaction: bases react with certain metal salts to form insoluble hydroxides as precipitates. For example, sodium hydroxide plus ferric chloride gives ferric hydroxide precipitate and sodium chloride. Fourth reaction: strong bases can react with fats in a process called saponification, producing soap and glycerol. From forming salts to creating soap, bases are an equally powerful partner in the world of chemistry. The root cause behind all these behaviors is ionization, the process of producing charged particles in water. Acids ionize to produce hydronium ions, while bases ionize to produce hydroxyl ions. If the ionization is complete, we have a strong acid or base. If it is partial, we have a weak one. This difference explains why some solutions are highly reactive and others are milder. Ionization also accounts for conductivity, corrosiveness, and predictable patterns in chemical reactions. In short, the presence and concentration of these ions are what give acids and bases their power. Knowing the properties of acids and bases is not just academic, it is essential for safety. This knowledge guides how we store, handle, and dispose of them. It also helps in identifying substances in the lab and understanding natural processes like digestion, where hydrochloric acid breaks down food, and blood chemistry, which is kept slightly basic to maintain life. In industry, these properties are exploited in everything from cleaning products to fertilizers. Let's quickly summarize the preparation methods for acids and bases. First, acids can be prepared from nonmetals, oxides, salts, or by direct synthesis. Second, hydrochloric acid is obtained by reacting sodium chloride with concentrated sulfuric acid, while nitric acid is prepared from sodium nitrate and concentrated sulfuric acid. Third, sulfuric acid is manufactured industrially through the contact process, which involves oxidation of sulfur dioxide and formation of oleum. Fourth, bases can be produced from metal oxides or carbonates, both of which yield strong hydroxides. And finally, displacement reactions using reactive metals can produce bases or ammonia solutions.